Very good morning, friends. Good morning and welcome to Unacademy. This is Abhijit, and today in this lecture, we are going to discuss about the uh, central dogma. Okay, so central dogma means replication, transcription, and translation. This all three processes comes under the central dogma. And today we have MCQs. I mean the top 25 MCQs from the central dogma. Okay, so before starting the lecture, few essential points. This is Crack Maharashtra CET channel, guys. If you do not have subscribed, first of all subscribe it and click on a bell icon, so you will have a notification prior to the lecture. Guys, before starting the lecture, it is necessary to know about me. This is Abhijit Madkar. I have more than 6 years of experience in the field of biology and also cracked NET CSIR from life science with all India rank 6.0. Guys, we are here on the India's largest platform. If you want to enjoy more uh, with Unacademy, so it is very necessary to download this app in your mobile. So guys, this link of this app is given below in the description of this video, so you can download this app from that link. Okay. So in this app there are thousands of educators and thousands of different type of lectures are available, so you can enjoy the topic whatever you want from the most of the time maybe it's your favorite educator, uh, so you can enjoy that topic with your favorite educator also. Okay. So guys, here is a Telegram app. If you have a Telegram app, then just go and find the Crack Maharashtra CET channel. That will give you all about the video lectures. Okay, so link for the lecture, then notes and the MCQs is also there on this Telegram app. So these are the few subscriptions from Unacademy. So guys, if you take a subscription of a 12-month, so fee is 14,850 rupees, and for 24 months it's 21,600 rupees. Okay, so if you use a capital Abhijit as a subscription code, you will have the 10% discount on the fee. Okay, so here it's a more than 2,000 discount, and here more than 1,400 rupees discount. Okay, so guys, why these subscriptions are necessary? So in that particular Unacademy app, the subscription will give you the unlimited use. What it means for example, you need a MCQs practice very prior to the examination. So that time this subscription will definitely help you for MCQs practice and after the MCQs practice. So this app will give you the analytical report. Okay, so that analysis will give you the idea about the which type of question you made a correct and which type of question you made a incorrect. So you will have the exact definition, exact direction for your study. Okay, so to decide the direction of your study, to decide the points to be revised from the syllabus, it is very necessary to uh, solve the test on the particular topic, and that will available under this subscription, and the other points available in this subscription is given below in the description, so you can go and read once. Okay, so you will have the idea about subscription, guys. But please keep in mind that whenever you are taking a subscription, this code will give you the 10% discount. So whatever subscription you are going to be take 1 month, 3 months, 6 months, 12 month, or the 24 months, all subscription will give you the 10% discount with this capital Abhijit as a subscription code. Okay, so let's start the central dogma. The first question is in the front of you guys. The final proof for DNA as a genetic material came from the experiment of. Okay, so we know there was a debate on the genetic material, either it is DNA, it is lipid, or it is protein, or it is carbohydrate. Then finally we got that it's not carbohydrate and the lipid, but DNA or protein. Okay, nucleic acid or the protein, it was the debate. And finally uh, Hershey and Case, the last experiment with the bacteriophage virus, okay, will uh, this was the last experiment that give us idea about the final proof of a DNA as a genetic material. Okay, so Hershey and Case was the last experiment. The second last experiment was the Avery, MacLeod and McCarthy. Okay, and this was the second last, and the first experiment was the Griffith experiment. Okay, and this is the last one, Hershey and Case. Griffith experiment was the experiment who give us the idea about the DNA as a genetic material. So there was one word, transforming principle. Okay, so whenever the lecture is over, please go and find the what is transforming principle and that the particular line about the Griffith experiment. Okay, so that will maybe that line will appear in examination. Transformation was discovered by uh, that is what I just told you, the one line about the transformation. It is just discovered by the Griffith. Okay, so Griffith. Antiparallel strand of a DNA molecule means what? Means that. So one strand turns anticlockwise. Second option. The phosphate group of two strands at their ends share the same position. The phosphate group at the start of the DNA strands are opposite pole or opposite position. One strand turns clockwise. Okay, so anti-parallel means guys, let's say what is meant by anti-parallel, how it looks like when we are talking about the DNA. Okay, so for example, this is DNA. Here is a phosphate group. So obviously this strand ends with a OH group. Okay, so OH group is always open at the 3' of ribose sugar, and this is open at the 5th carbon of the ribose sugar. So the 5' and the 3', and 3' is always at the opposite of a 5' strand, so it will show you the phosphate group at the 5th prime, 5' and it will show you the OH group at the 3'. Okay, so this is the anti-parallelity of the strand. Okay, so what is meant by guys anti-parallel? So the 3' at the one end and the same strand shows you the 5' at the second end, so same in other. So this 5' and 3' always at the opposite position on the opposite strand. Okay, so if you cut DNA here, so the one strand, when you cut here, so it will give you the 3' because the strand is ending at the 5'. If you cut this strand here, so it will give you the 3' to the 5'. Okay, so this is the anti-parallelity and the other things related to the DNA. Okay, so the correct answer is the phosphate group at the start of two DNA strands are opposite position. Okay, let's see guys, next question. What are the structure called that give rise an appearance as a beads on a string in the chromosome when viewed under the electron microscope? What is the structure which looks like the beads on a string? Okay, so what is meant by beads on a string? Beads on a string means, for example, you see like a structure like the thread which is having the circular spot. Okay, so this type of structure, if you see, it is called as a beads on a string. Okay, so there are two things where the beads on a string is we can appear beads on a string. Okay, so the first thing I'm going to say you about the polyribosome. Okay, polyribosome. So this is condition where the single mRNA is having the many ribosomes, which is translating the a protein at the same mRNA. Okay, so this structure, if you see under microscope, electron microscope, it looks like a beads on a string. But here the question is about your chromosome. Okay, so which structure is looks like a beads on a string? So guys, the correct answer is nucleosome. Okay, so nucleosome is a structure where the histone protein, octamer of a histone protein, octamer यासाठी की 8 प्रोटीन पासून बनतो म्हणून octa. Okay, so octamer of a histone protein which is having the DNA strand like this. So coming from the behind of the string, and again I'm moving toward the back side, again come and moving again toward the next thread. Okay, so here is your second bed or the second nucleosome. So the this structure is looks like a beads on a string. Here is also after the 2 round DNA is moving toward the second or the third nucleosome. Okay, so the nucleosome to nucleosome DNA is moving, and it is called as the nucleosome. Means if you start from here, from this point, and ends at this point, so the complete DNA present inside this 2 point is a 200 base pair. Okay, किती आहे 200 base pair. Out of this 200 base pair, this is a 54 base pair, and the complete bead or the complete ball, the ball of histone protein is having 146 base pair. Okay, 146 base pair on this a protein, and the 54 base pair on this it's called as a linker DNA. It is a joint between the two nucleosomes. Okay, so it is called as a linker DNA. So let's see the next question. मित्रांनो तुम्ही आन्सर करू शकता कोण जर तुम्हाला एखाद्या क्वेश्चनचा आन्सर माहित असेल किंवा तुम्हाला माहित नसेल तर तुम्ही परत विचारू शकता. एखादं एक्सप्लेनेशन नाही तुम्हाला समजलं तर एखादा क्वेश्चन परत विचारू शकता, काही डाऊट असेल तर. ठीक आहे. Nucleosome are the core. Nucleosome core is made up of. So nucleosome, I already told you, it is made up of the 8 proteins, and that's why it is called as octamer. Octa means 8. 8 protein. So these 8 proteins are the 2 copies each of 4 protein. Okay, so 4 proteins are there. So histones, this is the octamer of histone. Okay, so this histone group is classified into the H1, H2, H3 and H4. Okay, so guys, if you see H1 H2 is divided into the H2A and H2B. Okay, so this octamer made up of the 8 proteins, so 4 from this side and the 4 from the back side. Okay, so we can draw it like this. Okay, so this is octamer. This octamer is having the 2 round of a DNA. Okay, so not complete 2, 1.7 round, so it will cover the 146 base pair and moves toward the next round. Okay, so to avoid the unwinding from this point, H1 is always there. Okay, so this H1 is always there. So H1, you can cut H1 from here. So now you will have the S2AB and H3 and H4. So your answer is S2AB, H3 and H4. So 2 copies of S2A, 2 copies of S2B, 2 copies of H3 and 2 copies of H4. So total it's 8 protein, and that is we called it octamer. Okay, so octamer word is coming from the 8 protein. Guys, if you remove this H1, so DNA is unwind. I mean DNA start unwinding, and it is a sign of the expression of DNA, or you can say the when H1 is not bind to the DNA is mostly metabolically active, and if H1 is tightly bound, so DNA is not metabolically so active. So depending upon the binding of H1 and the absence of H1, we can calculate which gene is particularly the more active as compared to the other gene. Okay, The experimental proof for the semi-conservative replication of a DNA was first shown in, okay, we know that the experiment, the scientist who conduct the experiment, but most of the time we always forget about the uh, model organism. Okay, so this is the model organism which is used for the semi-conservative mode of replication. So semi-conservative mode of replication was studied in the bacteria. Okay, so it was studied in the bacteria. Ligase is an enzyme responsible for, okay, so ligase is actually the group of enzyme which is responsible for the joining. Okay, so joining of a DNA bit. So when DNA is completely synthesized, okay, for example this is a new strand. So we know there is a primer, and primer is always made up of RNA primer is there. Okay, so after the pol 3 moves from here, so your pol 1 comes, pol 1 comes and remove this primer. Okay, so here is a nick, okay, which nick shows the phosphate group at 5 prime end and the OH group at the 3 prime end. Okay, so the making a joint between OH and the phosphate is very essential, and that is actually done by your primates. Okay, it's seal nick. Okay, so this is your ligase which forms a bond, and finally the structure is looks like this. Hogness box or Tata box has a base sequence. Okay, so these are the box which is present on the minus 35. Okay, and the sequence is TATAAQ or sometimes TATAAT. Sometimes it's TATAAT. Okay, so this is also correct. This is also correct. The enzyme which help to cut one strand of a DNA duplex to release the tension of coiling of two DNA strand each. Okay, so at the time of replication and the time of transcription, at the both in this both processes, so one thing is common, that is the helicase enzyme, okay, which is responsible for the unwinding of a DNA. If DNA is not unwinded, so it is not available for the further metabolism, further processes. So the availability of DNA is very important, and it is available due to the uncoiling. Okay, so this uncoiling or the denaturation of a DNA is very importantly done by the helicase enzyme. But at the same time, when helicase is working on the denaturation process or the uh, unwinding process, that time automatically due to the unwinding at the one side or the particular side, automatically apply the pressure or the strain on the opposite side, I mean the side where the helicase is move. Okay, so the forward side is always highly coiled. Okay, so this supercoiling, this removal of supercoiling is very important, because DNA is very delicate molecule. It can be a cut due to the that strain. Okay, so the removing of strain is done by the cutting of a DNA duplex, or the one strand of a cutting of DNA duplex by the dash dash enzyme. So the question is like this. Okay, and DNA topoisomerase is your enzyme which is responsible for the removing or the release of a tension. Okay, so it releases the tension from the DNA which is applied due to the uncoiling. Okay, so the DNA topoisomerase. So there are two type of topoisomerase, topoisomerase 1, type 1 and the type 2. Type 1 cuts the one strand of a DNA, and that's why we called it a topoisomerase type 1. and type 2 cuts two strand of a DNA. It requires in a prokaryotic, let's see what happened in a prokaryote. Actually, in a prokaryote, there is theta model of replication. Okay, so the replication, for example, starting from here, so replication at a time moves toward the both sides. So it's a bidirectional in a prokaryote. Okay, it is a bidirectional in a prokaryote. Bi means two. So one side is moving toward the this and the second is moving toward the this direction. Okay, so after a few seconds you can see it's like this. So the replication is moving forward like this. Okay, so it now looks like a theta, and that's why it is called as theta, like a theta mode of replication. Finally we will have the two DNA which is grippled into the each other. Now you can't separate this DNA without cutting it at the both stand. Okay, so now if you say both DNA are now like this. Okay, so they, you can't separate them without cutting like this. Okay, so to separate them it is necessary to cut one strand of a DNA, then remove the second, and then again seal the first one. So at this moment we require the DNA which can cut both strand of a DNA, and again after the unwinding or the ungrippling, so again required to seal this, and the topoisomerase type 2 is required here. uh, so it can make a 2 DNA strand like this. Okay, and then the bacteria is start, it's a binary fission at the cytoplasmic level, and so it can separate from each other. Okay, so this is how the replication happens inside of a bacteria. It requires topoisomerase 2. Okay, I mean this is the best example where we can study the topoisomerase 2. Okay, so let's see next one. The unwinding of a DNA is carried out by enzyme. Unwinding of DNA is carried out by enzyme. So guys, we know it's a helicase enzyme, but unfortunately we do not have an option. So helicase enzyme is also called as unwindase. Okay, or this unwindase helicase, or they also called as swelase. Okay, so this is the one enzyme which is required for the unwinding of DNA. Okay, so your correct answer is swelase. The strand synthesized continuously and discontinuously are called. Okay, so it's a question from replication. Okay, we know the one strand which is synthesized continuously. Okay, so that strand is always 3 prime to 5 prime, 3 prime to 5 prime of DNA. So the new strand is 5 prime to 3 prime, but the second strand which cannot synthesize continuously. Okay, so not like this guys, that it is like this. Okay, so this strand is called as a lagging strand. This strand is called as a leading strand. Okay, so कंटिन्युअसली वाला फर्स्ट आहे, म्हणजे हा लीडिंग आहे. जो कंटिन्युअस ट्रान्सक्रिप्ट सॉरी रिप्लिकेट होतो त्याला लीडिंग म्हणतो आपण, आणि जो डिसकंटिन्युअस होतो त्याला लॅगिंग म्हणतो आपण. तर आन्सर काय असलं पाहिजे, लीडिंग आणि लॅगिंग. सो फर्स्ट ऑप्शन इज करेक्ट. ओके, सो टेम्पलेट स्टँड काय आहे आणि कोडिंग स्टँड काय आहे मित्रांनो. टेम्पलेट स्टँड आणि कोडिंग स्टँड आपण ट्रान्सक्रिप्शन ज्यावेळेस सुरू करू तर त्यावेळेस आपण पाहूया काय. Which of the following is not applicable for RNA? RNA मध्ये काय applicable नाही, complementary base pair. So if you see the structure of a tRNA, it will look like this. 3 prime, for example, 5 prime. So here is a 4 base pair. Okay, so the complete it's made up of 7 nucleotide, 4 base pair. So these 3 are the non-pair. Okay, so here is pairing, here is also pairing, here is also pairing. Okay, so we can say the complementary base pair is a present. Okay, 5 prime phosphate and 3 prime hydroxyl end. So it is already here, 5 prime phosphate group and the 3 prime OH group. Okay, so it is also correct. Heterocyclic nitrogenous bases, so it contain AUGC. So they are heterocyclic. I mean this is also correct. And the Chargaff's rule. Chargaff's rule is the purine is equal to pyrimidine. Purine always equal to the pyrimidine. Okay, so this rule is not followed by the RNA. And it is only by dsDNA. डबल स्टँडर्ड डीएनए. ओके, सिंगल स्टँडर्ड डीएनए सुद्धा या रोलला फॉलो करत नाही. फक्त आणि फक्त डबल स्टँडर्ड डीएनए ला हा रोल फॉलो करता येतो. आणि हा तुमच्या बुक मध्ये दिलेला आहे ए प्लस जी अपॉन टी प्लस सी. ओके, उलटा झालाय थोडा, ए प्लस टी अपॉन जी प्लस सी. ठीक आहे, आता बरोबर येईल. 1/1 आन्सर येतं. फायनली 1:1 रेशिओ येतो. आणि दॅट्स वाय वी कॉल्ड इट द प्युरिन इज ऑलवेज इक्वल टू pyrimidine. म्हणजे रेशिओ सारखा येतो. ओके, सो प्युरिन अँड द pyrimidine इज ऑलवेज इक्वल टू द 1. म्हणजे तुम्ही प्युरिन डिवायडेड बाय pyrimidine कराल तर आन्सर येतं सेम तुमचं. त्यामुळे आपण जर 100 बेस पेअरचा डीएनए घेतला, मी तुम्हाला म्हणलं 30 ए आहेत, तर जी बरोबर किती मित्रांनो? ओके, मग 30 असेल तर तुम्ही म्हणता सर 30 या बाजूला ए आहेत, तर बरोबर 30 टी असणार आहे. मग किती यातून 60 गेले, राहिले किती मित्रांनो? 40 हे जी आणि सी चं कंटेंट आहे, त्यातले 20 ची आणि सी 20. मग आन्सर 20 करता तुम्ही. हे कुठून कसं काढलं तुम्ही? चार्गाफ रूलचाच प्रकार आहे की नाही? हा त्याचंच ऍप्लिकेशन आहे की नाही? नेक्स्ट क्वेश्चन, which one of the following is not pair of a transcription unit in a DNA? Okay, which of the following is not part of a transcription unit in a DNA? ट्रान्सक्रिप्शन युनिट म्हणजे जीनचा भाग जो ट्रान्सक्रिप्शन मध्ये पार्टिसिपेट करतो. ओके, जीनचा म्हणजे डीएनए चा भाग असणार आहे. द इंड्युसर. ओके, सो लेट्स से if you are not sure about the inducer, so let's say just hold this option. A terminator, we know the terminator is here, which actually the stop the process of a transcription. So terminator is a part. A promoter, we know the promoter is a site where the DNA polymerase bind. Sorry, RNA pol binds here at the site. We call it the promoter. Okay, and the structural gene is a part actually which is going to be convert itself into the RNA and mostly mRNA, for example. So your inducer is not a part of a transcriptional unit in a DNA, because it is actually the protein or the molecule, anything molecule which is responsible for the initiation of a transcription. Okay, so if it's a lactoperon, so lactose is also act as inducer. Okay, we know that. So it doesn't mean that always it's a protein. Okay, so anything can be the inducer. Okay, inducer is not part of a DNA. It's actually a molecule which binds to the promoter most of the time and start the transcription of a DNA. Okay. A reverse transcription is a process of formation of a DNA from RNA. We know that the DNA to RNA It's called as transcription. Okay, it's a transcription. And when you move in the opposite direction, it is called as a reverse transcription. The enzyme which is required for reverse transcription is called as reverse transcriptase. Okay, so it is RNA dependent DNA polymerase. It is RNA dependent DNA polymerase which is discovered by the Baltimore and the Temin. Okay, so this is the correct option. The scientist who discovered this RNA transcription process or the RNA transcriptase. Okay, so it is discovered by the Temin and the Baltimore. Okay, so let's see the next one. Removal of RNA polymerase 3 from the nucleoplasm will affect the synthesis of tRNA, hnRNA, mRNA, and the rRNA. Let's see, guys, how you can calculate this thing. Okay, so the polymerase 1, polymerase 2, and the polymerase 3. Okay, so these are the three type of polymerase which is responsible for the making of RNA in our body. So polymerase 1 is responsible for making uh, rRNA. 2 is responsible for making mRNA. Okay, and pol 3 is responsible for making tRNA. And so your correct answer is a tRNA, because if you remove the pol 3 from the cytoplasm, uh, sorry, nucleoplasm, it will automatically stop the production of a tRNA. Okay, will affect the synthesis of what? tRNA, because it's a 3 is responsible for tRNA, 2 is responsible for mRNA, and the 1 is responsible for rRNA. Okay, so the simple one, guys. If one strand of a DNA has a nitrogenous base sequence as A, T, A, C, G. Okay, so the one strand of DNA, for example, this is strand of DNA, A, T, A, C, G. Then the nucleotide sequence in mRNA would be, okay, so for example, this is the one strand, second strand, maybe like this, T, A, T, G, C. Okay, so if you transcript it, it will transcribe like this. For example, the DNA RNA polymerase is moving like this. So here sequence is like C is opposite to the G. So here is a G. So let me draw here. C, here C. So A. Okay, it's a T. T is again A. So T is not there in RNA, so it's U. So if you see, guys, this option is not present. Okay, that means we are going wrong. No. Actually, they just give you the ATACG. So when the one strand is given in the question, the second strand we have to always draw it, and maybe the first strand is acting as a template for the making of RNA, because what we make the RNA is on this strand, the second strand. Actually, it is not acting as a gene here. So the condition is like that. Your gene is here on this strand. So when this strand is a transcripted, so it will give you the sequence like A in the front of a T. So it's a U, A, U, here is a G, and here is a C. Okay, so the sequence we got is U, A, U, G, C. Yes, this sequence is in the option, and the correct answer is U, A, U, G, C. So here is a template strand, and they never told anything about the template strand in a question, and that's why I draw first this strand as the template one. Okay, so whenever in examination you tried on a one strand, it doesn't mean that the answer is not coming. Mean there is question and there is something is wrong in a question. Okay, no guys, there is always second chance. Maybe the second strand is acting as a template strand, so it doesn't mean that guys each and every time the one strand is acting as a the template. Okay, so the second is also acting as a template. So how, let's see. So few of you now get confused. How, sir? How? It's just the sequence. If you see, sir, it's like a 3 prime to the 5 prime. Okay. So how can it happen? So here they never told you about the 5 prime to the 3 prime or the 5 prime to the 3 prime. Okay. So in this situation, this is acting as a template. We know that because the new DNA is, sorry, new RNA is the direction of making of a new RNA is 5 prime to the 3 prime. So it is correct. But how second is act as a 5 prime to the 3 prime, because it's already the 5 prime to the 3 prime. Okay. So if your gene is present on this strand, so this strand is a transcripted in this direction, and now it's a 5 prime to the 3 prime. Okay. So it doesn't mind the only one DNA strand is acting as a template. No, the both DNA strand is acting as a template depending upon the gene which is present on either the lower strand or the upper strand. And if you see the direction, it is always opposite to each other because the DNA is anti-parallel. Okay. Let's see next one. The mRNA sequence in eukaryotes which do not code for anything are called, which do not code for anything. Okay, so the introns we always cut from the mRNA, so it is always in a eukaryote. We call it a splicing process. Okay, intron and these exons are cut and again joints to form the functional mRNA, and the process is called as a splicing. Okay, so it happens after the transcription, so it is called as a post transcription modification. Of mRNA or the post-transcriptional modification or the post-transcriptional events. Okay, so the answer is intron. Nonsense codon takes part in nonsense codon. So it is not nonsense means it is not code for the amino acid. It is not code for any amino acid. Okay, so it now takes part in a transcription. So what it does actually, so guys, these codons are responsible for the termination process. Okay, so answer is a terminating message of a gene controlling protein synthesis. Okay, formation of unspecified amino acid. So no, it is also wrong. The conversion of sense DNA into the nonsense one. So no, release tRNA from the polypeptide chain. No. So the correct answer is termination message of a gene controlling protein synthesis. Okay, so let's see the next one. In a translocation on a ribosome, the amino acid shifts from the A site to the P site, tRNA to A site, tRNA to P site, and P site to the A site. Okay, so the first thing, what is meant by site on this? For example, this is the mRNA. This is your the small subunit of ribosome. This is ribosome, which is having 3 sites. So one is a P, one is a, and the one is E site, exit site. Okay, so entry site, here is A site, P site, and the E site, exit site. Okay, for the tRNA. So when tRNA shift from A site to the P site is called as a translocation process. Okay, so in the translation chapter, I already discussed about this translocation process in a very detail. So please go and find the details about translocation. It's very important topic, guys. If the question, uh, uh, I mean the paper setter wants to increase the hardness of a question from this topic, the translation. So the translocation is a best option for them. Okay, so it is also best option for you to prepare because it's an easy process, required some energy and the other things which is already I explained in the translation process. Okay, so please go and find it after the lecture. Which one of the following hydrolysis the internal phosphodiester bond in a polynucleotide chain? It means that, for example, this is a DNA. So internal means from here. For example, it is cutting here or the cutting here means internal. If it is started cutting from the last side or the end, it's called as exonuclease. Exonuclease. We start the cutting of a DNA from the one side like this. Okay, but it is cut the DNA between the length is called as the endonuclease. Okay, so endonuclease is having its three type. I mean, the few endonucleases can cut the DNA at specific time. Sometimes they cut a DNA at a specific site, not a time. It's a specific site. Specific site. If at it cut it's a DNA at a specific site, it is called as restriction endonucleases. Endonucleases, that is REN. Okay, REN, which is used in a biotechnology. Okay, so this REN shows it's three groups in the cell. So group 1, type 1, type 2 and the type 3. Okay, these are the type. So type 1 it does not show the very good specificity, so it is not used in biotechnology. And type 3, when the type 3 find it's a site of a recognition or the site of a cutting, so that time it just for example, this is a site, so it just cut either this side or this side the 1000 base pair, about 1000 base pair away from the site of recognition. So it is not again the used in a biotechnology, but at the site the enzyme which cut DNA at a specific site is a type 2, and that's why the type 2 is used in a biotechnology. Okay, so the type 2 REN used in a biotechnology. So the question is actually coming from biotechnology, so I explain it. Endonucleases. This question is not coming from the digestive system, guys. Okay, so endonucleases is not clearly explained in your digestive system. In digestive system, most of the things which is explained about the nucleotides, the nucleosides, and the nucleases, but not about the endonuclease and the exonuclease. This enzymes is a part of your biotechnology, REN. Okay, RDNA technology मध्ये explain करून दिलेला आहे. The gene and the cistron words are sometimes used synonymously because gene आणि cistron एकच ठिकाणी वापरू शकतात. हे वर्ड वापरले जातात अल्टरनेटली. ओके, कारण काय त्याचं, तर वन सिस्ट्रॉन कंटेन मेनी जीन्स. एका सिस्ट्रॉन मध्ये खूप सगळे जीन्स असतात. वन जीन कंटेन मेनी सिस्ट्रॉन, one gene contain one cistron, and the one gene contain no cistron. So the correct answer is one gene contain one cistron. एका जीन मध्ये एक सिस्ट्रॉन असतो. सिस्ट्रॉन म्हणजे ट्रान्सक्रिप्टेबल युनिट. ओके, तो जो मधला पार्ट आहे त्याला सिस्ट्रॉन म्हणता तुम्ही. एका जीन मध्ये एकच असतो. ऍक्च्युअली तो एक असतो म्हणून तो एक जीन आहे. ओके, ऑल ऑफ म्हणून तुम्ही जे काही तुमचे युकॅरियोटिक जीन आहेत ना त्यांना मोनोसिस्ट्रॉनिक म्हणता की नाही युकॅरियोटिक. फॉर एक्झाम्पल हा प्रमोटर आहे. ओके, हा प्रमोटर, मग हा ट्रान्सक्रिप्टेबल युनिट, याला ट्रान्सक्रिप्टेबल युनिट म्हणतो आपण, आणि हा इकडला टर्मिनेटर फॉर एक्झाम्पल. मग इथून एक प्रोटीन तयार होत, एक mRNA तयार झाला आणि याच्यापासून एक प्रोटीन तयार झाला. याला तुम्ही म्हणता मोनोसिस्ट्रॉनिक. हा सिस्ट्रॉनिक शब्द वापरायची गरजच ती आहे. ओके, जर तुम्ही बॅक्टेरिया पाहिला तर बॅक्टेरियामध्ये सेम सिच्युएशन असते, हा प्रमोटर रिजन, हा डीएनए आणि टर्मिनेटर. ओके, इथे पण एक mRNA तयार होतो, पण या एक mRNA पासून पुढे मात्र 2-3 प्रोटीन तयार होतात. आणि याला आपण म्हणतो पॉलिसिस्टॉनिक. ओके, तुम्ही म्हणाल तुम्ही तर सांगितलं होतं 1 जीन कंटेन 1 सिस्टम, हे 3 जीन आहेत असे तुकडे तुकडे आहेत की नाही? ए, वाय आणि झेड असे नाव वगैरे ऐकले असतील तुम्ही. नसेल तर माझा ओपेरॉन नावाचा एक लेक्चर अवेलेबल आहे, ते एकदा चेक करून घ्या, त्याच्यामध्ये मी या गोष्टी एक्सप्लेन केलेल्या आहेत. ऑल ऑफ द फॉलोविंग आर द पार्ट ऑफ ओपेरॉन, त्याच्यावरतीच क्वेश्चन आहे, एक्सेप्ट ऑफ. सो ओपेरॉन आता जे स्ट्रक्चर काढलं होतं मी जीनचं सेम आहे. हा प्रमोटर रिजन आहे, त्यामुळे हा जर प्रमोटर असेल तर हाच आहे. ऑपरेटर रिजन पण असतो याच्यामध्ये, ऑपरेटर रिजन त्याच्याच बाजूला आहे, तो ऑपरेटर रिजन त्याच्या अलीकडल्या बाजूला आहे, ज्याचा इनॅन्सर वगैरे जो बनतो, तर तो स्ट्रक्चरल रिजन पण असणार आहे त्याच्यामध्ये. फक्त इनॅन्सर नसतो, इनॅन्सर मित्रांनो हा तुमच्या जीनचा पार्ट नसतो तिथे. ठीक आहे, सो विच ऑफ द फॉलोइंग, all the following are the part of operon except of enhancer. Okay, enhancer त्याचा पार्ट नाहीये. ठीक आहे, ह्युमन जीनोम प्रोजेक्ट was coordinated by which country? USA ने केलं तर आपल्याला माहिती आहे, USA, उगा जपान चायना वगैरे लिहित बसू नका. USA यांचं कॉन्ट्रीब्युशन होतं, जपानचं, चायनाचं, युरोपचं, इंडिया पण कॉन्ट्रीब्युटेड आहे त्याच्यामध्ये. पहिल्या 7 कंट्रीज मध्ये इंडिया पण येतो, असं काही नाही, पण USA ने तो कोऑर्डिनेट केलं. ठीक आहे. Which of the following is required as an inducer for the expression of a lactoperon? इंडुसर म्हणजे काय, तर जो लॅकोपेरॉनला स्टार्ट करून देतो, तर लॅकोपेरॉन आहे. लॅकोपेरॉन म्हणजे लॅक स्टँड्स फॉर लॅक्टोज. ज्यावेळेस ग्लुकोज अवेलेबल नाही आणि सराउंडिंग मध्ये लॅक्टोज अवेलेबल आहे, त्यावेळेस लॅक्टोज खायला अवघड जातो मित्रांनो. एक तर त्याला आतमध्ये घ्या, आतमध्ये घेण्यासाठी स्पेशल अरेंजमेंट पाहिजे, आणि दुसरी गोष्ट म्हणजे त्याला डायजेस्ट करताना लॅक्टोजला डायजेस्ट करावं लागेल तुम्हाला 2 गोष्टीमध्ये. हा कट केल्यावरती तयार होणार ग्लुकोज प्लस गॅलॅक्टोज. म्हणजे पहिलं तर हा मधला बॉन्ड तोडायचा आहे, म्हणजे तुम्हाला एक डायसॅकॅरिडेज पाहिजे. ओके, डायसॅकॅराइडला कट करणारे एन्झाईम, आणि ते लॅक्टेज असलं पाहिजे, बरोबर की नाही, याला मध्ये कट करणार. तर ऍक्च्युली यासाठी तुमचा लॅकोपेरॉन स्टार्ट करावा लागतो, आणि लॅकोपेरॉन स्टार्ट करायला इंडुसर म्हणून तुमचा लॅक्टोज काम करतो स्वतः. ठीक आहे, पहिला लॅक्टोज जो आतमध्ये येतो आणि इंडुसर म्हणून ऍक्ट होतो, तर त्याला आपण आलो लॅक्टोज म्हणतो. आलो लॅक्टोज. ओके, ड्युरिंग अ ट्रान्सक्रिप्शन RNA पॉलिमरेज होलो एन्झाईम, होलो एन्झाईम म्हणजे कम्प्लीट एन्झाईम. ओके, कोर एन्झाईम तुम्हाला माहिती आहे, को फॅक्टर जे असतात एन्झाईमचे, त्याला को एन्झाईम्स म्हणतो आपण. को एन्झाईम आणि जो कम्प्लीट कोर एन्झाईम आहे, तर हे ज्यावेळेस बाइंड होतात, होलो एन्झाईम, कम्प्लीट एन्झाईम तयार होतो. बाइंड्स टू अ जीन प्रमोटर अँड assumes a saddle like structure. सॅडल म्हणजे ज्याच्यावरती बसतात ना, मोस्टली सॅडल म्हणजे सीटेबल. ओके, त्याला कम्फर्टेबल वाटतंय तिथं बसल्यानंतर. म्हणजे क्वेश्चन काय आहे बघा, की RNA पॉलिमरेज आहे, हा एन्झाईम ज्यावेळेस जीनच्या प्रमोटर रिजनला बाइंड झाला, त्यावेळेस त्याला कम्फर्टेबल वाटतंय बसायला. सो व्हॉट इज इट्स बाइंडिंग सिक्वेन्स, त्याची बाइंडिंग सिक्वेन्स काय असली पाहिजे, कुठं बसला असेल तो, असं विचारलंय. सरळ सरळ तुम्हाला ज्या ठिकाणी बाइंड होतो ना, ती जागा म्हणजे प्रमोटर रिजन. ओके, या प्रमोटर रिजनची सिक्वेन्स विचारलेली आहे. प्रमोटर रिजनची सिक्वेन्स तुम्हाला माहिती आहे की -35 ला तुम्हाला टाटा बॉक्स आहे, आणि टाटा बॉक्सची सिक्वेन्स TAT AET आहे. ओके, त्यामुळे हा सिक्वेन्स जो आहे, क्वेश्चन जो आहे, तर टाटा बॉक्स से रिलेटेड आहे. टाटा बॉक्सलाच आपण हॉग्नेस बॉक्स म्हणलो होतो मागाशी, आणि हा युकॅरियोटिक मध्ये म्हणलं जातं याला, हॉग्नेस वगैरे. हॉग्नेस, टाटा बॉक्स किंवा हॉग्नेस बॉक्स हे युकॅरियोटिक मध्ये आहे मित्रांनो. प्रोकॅरियोटिक मध्ये जर तुम्ही पाहिलं, तर या प्रोकॅरियोटिक मध्ये, प्रोकॅरियोट्स यामध्ये टाटा बॉक्सला प्रिब्नो बॉक्स म्हणतो आपण, प्रिब्नो बॉक्स. ओके, so thank you very much guys. So today we will have again lecture at the 9 p.m. okay. on tomorrow, I mean the daily at the 7 a.m. So schedule your time and be on a time. If you ask the question, I will definitely explain you. Okay. And so guys, the very important last very important thing, this is Crack Maharashtra CET channel. If you have, do not sub if you do not have subscribed, first of all subscribe it and click on a bell icon. Telegram will give you the link and the other things related to the study, and this capital Abhijit will encourage your the conveniency with the subscription by decreasing your fee by 10%. Okay, so 10% discount with this code. Okay, so thank you very much and have a good time, guys. Bye bye.